Section 5.6 Equations with Decimals. In this video we will see how to undo decimal number operations on equations and how to combine operations when solving equations with decimals, how to combine like terms containing decimals, how to distribute decimals using the distributive property, how to approximate solutions of an equation, and applications of equations containing decimals. We can add or subtract the same decimal number from both sides of an equation without affecting the solution. Example 1. Solve for x in the equation x minus 1.35 equals negative 2.6. Solution: to undo subtracting 1.35, add 1.35 to both sides of the equation. We get x minus 1.35 plus 1.35 on the left and negative 2.6 plus 1.35 on the right. So on the left, negative 1.35 plus 1.35 is 0, so we're left with x, and on the right, negative 2.6 plus 1.35 is negative 1.25. So x equals negative 1.25. We can still multiply both sides of an equation by the same decimal number without affecting the solution. Example 2. Solve for x in the equation x divided by negative 0.35 equal to 4.2. Solution: to undo dividing by negative 0.35, multiply both sides of the equation by negative 0.35. On the left, we have negative 0.35 times x divided by negative 0.35 equal to negative 0.35 times 4.2 on the right. On the left, we're left with x, and on the right, we have negative 1.470. We can still divide both sides of an equation by the same decimal number without affecting the solution. Example 3. Solve for x in the equation negative 1.2x equals negative 4.08. Solution: to undo multiplying by negative 1.2, divide both sides of the equation by negative 1.2. So on the left, we have negative 1.2 times x divided by negative 1.2, which is x, and on the right, we have negative 4.08 divided by negative 1.2, which is a positive 3.4. Since both are negative, we get a positive result, so x equals positive 3.4. Combining operations. We sometimes need to combine operations. Example 4. Solve for x. In the equation negative 3.8, x minus 1.7 equals negative 17.28. Solution: to undo subtracting 1.7, add 1.7 to both sides of the equation. So on the left, we have negative 3.8x minus 1.7 plus 1.7, which is negative 3.8x. And on the right, we have negative 17.28 plus 1.7, which is a negative 15.58. Next, to undo multiplying by negative 3.8, divide both sides of the equation by negative 3.8. So on the left, we have negative 3.8 times x divided by negative 3.8, which results in x. And on the right, we have negative 15.58 divided by negative 3.8, which results in a positive 4.1. Combining like terms. Combining like terms with decimal coefficients is done in the same manner as combining like terms with integer coefficients. Example 5. Simplify the expression negative 3.2x plus 1.16x. Solution: to combine these like terms, we must add the coefficients. To add coefficients on like signs, first subtract the coefficient with the smaller magnitude from the coefficient with the larger magnitudes, then prefix the sign of the decimal number having the larger magnitude. Hence, negative 3.2 plus 1.16 equals a negative 2.04. We can now combine like terms as follows. Negative 3.2x plus 1.16x equals a negative 2.04x. When solving equations, we sometimes need to combine like terms. Example 6. Solve the equation for x. 4.2 minus 3.1x plus 2x equals negative 7.02. Solution: combine like terms on the left-hand side of the equation. Negative 3.1x plus 2x is a negative 1.1x on the left. Now we'll solve the equation. We want to get the variable term by itself, so we will subtract 4.2 from both sides. So on the left, we have 4.2 minus 1.1x minus 4.2, which is a negative 1.1x. And on the right, we have negative 7.02 minus 4.2, which is a negative 11.02. Then we'll divide both sides by negative 1.1 to get x by itself. So on the left, we have negative 1.1 times x divided by negative 1.1, so we're left with x on the left. And on the right, we have a negative 11.22 divided by negative 1.1, which is a positive 10.2. So the result is x equals 10.2. We can check the solution by substituting the number in the original equation. If we let x equals 10.2, we get 4.2 minus 3.1 times 10.2 plus 2 times 10.2 equals negative 7.02. So on the left, we will multiply first by order of operations. So 3.1 times 10.2 equals 31.62, and 2 times 10.2 equals 20.4. Then we'll add and subtract moving left to right. 4.2 minus 31.62 is a negative 27.42, and negative 27.42 plus 20.4 is a negative 7.02. Since both sides are equal, that is, the last line is a true statement, the solution x equals 10.2 checks. Using the distributive property. Sometimes we will need to employ the distributive property when solving equations. Let a, b, and c be any numbers, then a times the sum of b and c equals the product of a and b plus the product of a and c. Example 7. Solve the equation for x. Negative 6.3x minus 0.4 times the difference of x and 1.2 equal to negative 0.86. Solution. We first distribute the negative 0.4 times each term in the parentheses, then combine like terms. So we have negative 0.4 times x is negative 0.4x, and negative 0.4 times a negative 1.2 is a positive 0.48. We'll combine like terms on the left. Negative 6.3x minus 0.4x is a negative 6.7x. We want to get the variable term by itself, so we'll subtract 0.48 from both sides. So we get negative 6.7x plus 0.48 minus 0.48 on the left, which leaves us with a negative 6.7x on the left side of the equation. And on the right, negative 0.86 minus 0.48 leaves us with a negative 1.34 on the right. We want to get x by itself. We'll divide both sides by negative 6.7. So on the left, we have negative 6.7 times x divided by negative 6.7, which leaves us with an x on the left. And on the right, we have a negative 1.34 divided by a negative 6.7, which leaves us with a positive 0.2 on the right. So x equals 0.2. Rounding solution. Sometimes an approximate solution is adequate. Example 8. Solve the equation 3.1x plus 4.6 equals 2.5 minus 2.2x for x. Round the answer to the nearest tenth. Solution. We need to isolate the terms containing x on one side of the equation. We begin by adding 2.2x to both sides of the equation. So on the left we have 3.1x plus 4.6 plus 2.2x, which results in 5.3x plus 4.6 on the left. And on the right we have 2.5 minus 2.2x plus 2.2x, results in a 2.5 on the right. To undo adding 4.6, subtract 4.6 from both sides of the equation. So on the left we have 5.3x plus 4.6 minus 4.6 is 5.3x. And on the right, 2.5 minus 4.6 is negative 2.1. To undo the effect of multiplying by 5.3, divide both sides of the equation by 5.3. So on the left, 5.3 times x divided by 5.3 is x. And on the right, negative 2.1 divided by 5.3 approximately equals negative 0.4. The solution rounded to the nearest tenth. To round the answer to the nearest tenth, we must carry division out one additional place value. So we divide to get a quotient of 0.39. Because the test digit is greater than or equal to 5, add 1 to the rounding digit and truncate, leaving us with approximately negative 0.4. Applications. Let's look at some applications that involve equations containing decimals for convenience. We repeat the requirements for word problem solutions. 1. Set up a variable dictionary. You must let your readers know what each variable in your problem represents. This can be accomplished in a number of ways. Statements such as let P represent the perimeter of the rectangle, labeling unknown values of the variables in a table, labeling unknown quantities in a sketch or diagram. Set up an equation. Every solution to a word problem must include a carefully crafted equation that accurately describes the constraints in the problem statement. 3. Solve the equation. You must always solve the equation set up in the previous step. 4. Answer the question. This step is easily overlooked. For example, the problem might ask for Jane's age, but your equation solution gives the age of Jane's sister Liz. Make sure you answer the original question asked in the problem. Your solution should be written in a sentence with appropriate units. 5. Look back. It is important to note that this step does not imply that you should simply check your solution in your equation. After all, it's possible that your equation incorrectly models the problem situation. So you could have a valid solution to an incorrect equation. The important question is, does your answer make sense based on the words in the original problem statement? Let's start with a rectangular garden problem. Example 9. Molly needs to create a rectangular garden plot covering 200 square meters. If the width of the plot is 8.9 meters, find the length of the plot correct to the nearest tenth of a meter. Solution. We will follow the requirements for word problem solutions. 1. Set up a variable dictionary. We will use a sketch to define our variables. Note that L represents the length of the rectangle. 2. Set up an equation. The area A of a rectangle is given by the formula A equals L times W, where L and W represent the length and width of the rectangle, respectively. Substitute 200 for A and 8.9 for W in the formula to obtain 200 equals L times 8.9, or equivalently, 200 equals 8.9 times L. 3. Solve the equation. Divide both sides of the last equation by 8.9, then round your answer to the nearest tenth. So on the left, 200 divided by 8.9 is approximately 22.5, and on the right, 8.9 times L divided by 8.9 is L. So L approximately equals 22.5. To round the answer to the nearest tenth, we must carry the division out one additional place value, so to the hundredths place value, getting us the quotient 22.47. Because the test digit is greater than or equal to 5, add 1 to the rounding digit and truncate. Therefore, 200 divided by 8.9 approximately equals 22.5. 4. Answer the question. To the nearest tenth of a meter. The length of the rectangular plot is L approximately equals 22.5 meters. 5. Look back. We have L approximately equals 22.5 meters and W equals 8.9 meters. Multiply length and width to find the area. Area approximately equals 22.5 meters times 8.9 meters approximately equals 200.25 meters squared. Note that this is very nearly the exact area of 200 square meters. The discrepancy is due to the fact that we found the length rounded to the nearest tenth of a meter. Example 10. Children's tickets to the circus go on sale for $6.75. The Boys and Girls Club of Eureka has $1,000 set aside to purchase these tickets. Approximately how many tickets can the Girls and Boys Club purchase? Solution. We'll follow the requirements for word problem solutions. 1. Set up a variable dictionary. Let n represent the number of tickets purchased by the Boys and Girls Club of Eureka. 2. Set up an equation. Note that the price per ticket times the number of tickets is the full purchase price. Hence, our equation is 6.75 times n equals 1,000. 3. Solve the equation. Divide both sides of the equation by 6.75. On the left, 6.75 times n divided by 6.75 equals n. And on the right, 1,000 divided by 6.75 approximately equals 148. Push the decimal point to the right end of the divisor and the decimal point in the dividend an equal number of places. We'll stop the division at the units position. So we get a quotient of 148. Answer the question. The Boys and Girls Club can purchase 148 tickets. 5. Look back. Let's calculate the cost of 148 tickets at $6.75 a piece. So 675 times 148 is 99,900. There's a total of 2 decimal places to the right from our original numbers. So we will place the decimal point with 2 digits to the right. So the result is 999. Thus, at $6.75 a piece, 148 tickets will cost $999. Because the Boys and Girls Club of Eureka has $1,000 to work with, note that the club doesn't have enough money left for another ticket. Example 11. Marta has 20 feet of decorative fencing, which she will use for the border of a small circular garden. Find the diameter of the circular garden correct to the nearest hundredth of a foot. Use pi approximately equals 3.14. Solution. The formula governing the relation between the circumference and diameter of a circle is c equals pi d. The 20 feet of decorative fencing will be the circumference of the circular garden. Substitute 20 for c and 3.14 for pi. So 20 equals 3.14 times d. Divide both sides of the equation by 3.14 to get d equals 20 divided by 3.14. Move the decimal point to the end of the divisor, then move the decimal point in the dividend an equal number of places, 2 places to the right. Note that we must add 2 trailing zeros in the dividend. Thus, the problem becomes, we need to round to the nearest hundredth. This requires that we carry the division 1 additional place to the right of the hundredths place, i.e. to the thousandths place. So we get the quotient 6.369. For the final step, we must round 6.369 to the nearest hundredth. In the schematic that follows, we box the hundredths digit, the rounding digit, and the test digit that follows the rounding digit. Because the test digit is greater than or equal to 5, we add 1 to the rounding digit, then truncate. Therefore, to the nearest hundredth of a foot, the diameter of the circle is approximately 6.37 feet.